Hi guys, this is topic 3.1. This is the problems part, the questions during lecture, the practice problems that I usually cover. So there's a couple. I want you to watch this so you can understand what to look for when you're answering these types of questions. Pentane C5H12 and octane H818 are both considered hydrocarbons. Identify the type of intermolecular forces present, and predict the substance that would have a higher vapor pressure and justify your claim. Both molecules would only exhibit LDFs, since both are made up from carbon and hydrogen bonds and carbon-carbon bond, which have negligible electronegativity differences. So both molecules would have or exhibit London dispersion forces, LDFs. For some reason my pen is being weird, so please pay attention to my words. Predict the substance that will have the higher vapor pressure and justify your claim. So whenever you look at the chart from lecture today, from your group activity, you have to, it said that vapor pressure would vapor pressure would decrease as IMFs increase. So between these two, of C5H12 and C8H18, C5H12 has, that's not C15, C5H12 would have higher vapor pressure, because it is less polarizable than C8H18 as it has fewer electrons. This means the IMF is weaker IMFs means C5H12 vaporizes more readily. So that means it has a higher vapor pressure. The boiling point of HF is 293 Kelvin, and the boiling point of F2 is only 85 Kelvin. Determine the type of intermolecular forces present, and explain the difference in boiling points based on their intermolecular forces. HF has hydrogen bonding, dipole-dipole, and LDF, while F2 only has LDFs. So it tells you that HF has a higher boiling point. It's not like a fact you are disputing. They're looking for your rationale and you justifying why that is considered the case. HF has a higher boiling point because the hydrogen bonding and LDF are stronger and hold the molecules together more tightly than the LDFs only in F2. This means that it takes more energy to separate the molecules in HF. Alright, gentlemen, that's it for now. Please let me know if any questions. Thanks, bye.